Hello everyone, my name is Vijay Golla. Welcome to my presentation on comparative study of operating system. So today I will be explaining the fundamental of the difference between major operating systems, focusing on their architectural design, so performance characteristics and implementation of strategies. So this analysis accomplishes how different operating systems manage system resources, implement security models, and design user interfaces. So by the comparing these systems side by side, we can better understanding their strength, limitations, and operating user case so in today's computing landscape. So we'll go with the next slide. So this one is like a introduction and objectives. So the objectives of the study of the multiplication first, I am to identify key architectural difference between major operating system and how these difference will impact performance and security. So the second, I will be analyze of various process and memories management techniques and that different operating systems employ to maximize efficiency. So the third, I will evaluate file system structure and their influence on data storage and retrieval operatives. So the capabilities and protocol implementation across different operating environments. So the final will assess user interface design and how effectively they share user across different computing context. So this is all for the introduction and objectives. So we'll go for the next slide. So this one is like a operating systems and overview. So let me briefly introduce the major operating systems covered in this study. So the window encourages backward compatibility and extensive hardware support. So maintaining the dominance in the both consumer and enterprises environments. So the Mac OS integrates hardware and software within Apple's ecosystem. So prioritizing the security and user experience through its controlled environments. So the Linux provides unparalleled flexibility with its open source model designs and allowing a customization for servers, desktop, and embedded application. So the Android extends the Linux kernel for mobile device, implementing the application sandboxing and touch-oriented interfaces. So the iOS prioritization performance through trigger hardware integration and maintenance strict control over the application. So environment to ensure security and stability. So this is all for the operating systems overview. We'll go to the next slide. So this was like historical development of the timeline. So understanding the historical context of operating system helps to explain their current design philosophies and Unix established the foundation of modern operating system in 1969 and introducing the directorial file system and the multi-user capabilities that influence all the contemporary systems. Microsoft's release of Windows NT in 1993 created the architectural foundation. So that still under the modern Windows system. So the Linux kernel development began in 1991. And Apple's transition to the Unix-based Mac OS in 2001 marked a significant shift. So, combining a robust kernel architecture with their intuitive interface design. So, finally, modern mobile operating systems engaged after 2007 and adopting traditional OS concepts for touch interfaces and resource contributed device. This is all for the historical development. So, we go for the next slide. So this is like a architectural foundation. So operating system architectures follow several foundation designs. Monolithical kernels, intelligence all OS services into a single memory space and maximizing performance, but potential increasing vulnerability if a component fails. So microkernel architecture like separates the core function from user services. So enhancing stability through um, isolation, but often at the cost of some performance. So the hybrid kernels attempt to combine advantages of the both approaches, balancing like performance considered with the stability and the security benefits. So providing minimal hardware abstraction, allowing applications of direct resource access for the maximum performance in a specialization scenario. So these are for the architecture foundations. So we'll go for the next slide. This one is the process management. So process management involves a significant different in operating system philosophies. So Windows implements a primitive multiple asking with priority based scheduling. So dynamically adjusting the priorities based on process behavior to optimize responsibilities. So Linux utilizes the compatibility fade scheduler and ensuring processors time allocation to all process regardless like of total system load. So the Mac OS employs great central dispatch for efficiently task parallelization and automatically distributing the workload across every process flows. So they're all for the process management. So we'll go with the next slide. So this is the memory management system. So the memory management system is crucial for system performance and stability. So the virtual memory implementation of the map programming addresses to physical location, allowing the systems to efficiently utilize availability memory while isolating process from one another. So the pegging system dividing memory into fixed size blocks. So facilities the differential allocation and providing protection between process memory spaces. So the some system employs segmentations or organization memory according to logical divisions within programs. So rather than the uniform physical blocks. So phase deployments or algorithms becomes critical when physical memory is fully utilized. So determining the which memory phase is to swap to disk. All modern operating system implement memory protection mechanism to prevent process from access memory, modifying the memory allocated to their process. So these are for the memory management system. So we'll go for the next slide. So this is the file system architecture. The file system architecture demonstrated significant design verifications across the operating system. So Windows primarily uses NTFs, providing a generating encryption compression, and access control leads while supporting large volumes. So Linux typically employs extract 4, so which enhance the performance through the delayed allocation and a faster life system. 6, we are improving the handling of large directories. So the Apple's optimizing for solid state storage with the COP on write. So design built-in encryption and efficient space sharing between our volumes. So the file system journaling has become standard across modern operating systems. So operating a date corporation by recording pending operation before execution. So virtual file system providing abstraction layers, offering a uniform access interface regardless of the underlying storage technologies. So these are for the file system architecture. We will go with the next slide. So this is the security models and the implementation. The security implementation varies significantly between operating systems. So the Windows implement a user account control for privilege evaluations on the user, the security support providing interface for authentication services. So unique based system traditionally rely on discretionary access control through the file performance design defining read and write executive privileges for owner. So group and others. So enhanced security model like SC Linux and app armor and providing mandatory access control. So restricting the programs to the predefined behavior regardless of user prevision. So applications like sandboxing and has become increasingly important. So isolating applications to the contain potential security branches. So these are for the security models and implementation. So we will go with the next slide. So this is like a user interface design. The user interface design reflects the fundamental differences in operating system philosophies and command line interfaces continue to offer appreciation on the scriptability while graphical interfaces priorities and discoverability and escape of learning for new users. So the Windows has maintained backward compatibility while gradually revealing its interface programs and sometimes with control visual change like the Windows 8 Star Scroll and Mac OS like Emphasize contains interface the guidance slides across the applications with a gradual reference rather than traditional design. So these are for the slide 10 like user interface design. So we will go with like next slide. This is like a performance benchmark. So performance benchmarking reveals how operating systems optimize for different workloads. So the CPU intensive testing show significant variation between operating systems. running an identical application, reflecting scheduler and effective and system call overhead. So the input-output operations demonstrate different priorities. So within some system favoritism through while others minimize latency for improved responsives. And the memory management efficiently directly impacts system responsiveness. So particularly when approaching physical memory capability limits, boot time measurement results obtain different in utilization process and service loading sequences. So these are for the performance benefits. So we'll go for the next slide. So this is the resource utilization. So resource utilization strategies differ significantly across operating system. So the process prioritization mechanism, like after how CPU resources are allocated when multiple applications compete for a processing item. So the memory compression techniques have engaged in several systems to reduce physical memory requirements by compressing in frequently accessed pages. So the input-output scheduling algorithms determine the sequence for accessing storage device. So balancing through the needs with the latency requirement for different application types. So the kernel resources management influence of overall system efficiency, practical under heavy loaded or in a resource contribution environments. So the power management features adjustment component performance are based on workload demands and optimizing battery life or engagement consumption. So these are the resource utilization. So we will go with the next slide. So this is a networking capabilities. So the networking capabilities have become increasing crucial for modern computer protocol implementation of the quality significance affect throughout like reliability and security of networking communications and across different operating systems. So the equality of service control allows prioritizations of critical network traffic practically implement for real time applications like video conferencing and VPN integration simplification source remote access with varying levels of configuration, complexes and performance impact between systems. So wireless networking features dramatically impact the mobile device usability with a significant different in roaming capabilities and connection stability. So the network stack efficiency directly influence our battery life of portability device and overall systems performance during the network instance of the operations. So this one will like our networking capabilities. So we go with next slide. So this is the virtualization and containerization. So virtualization and containerization support has become essential for a modern computing environments. So the hardware virtualization support enables efficient execute of the virtual mechanism with a minimal performance of the overhead compared to bare metal installation. So the hypervisor implementation for vary between operating systems, so affecting virtual machine performance, security, and management capabilities. So container technologies provide applications isolation with lower overhead than fuel virtualization by sharing kernel resources. So resource allocation policies determine how computing resources are distributed between a host system and a virtualization environments. So these are for the virtual and containerization system. So we will go with the next slide. So this is the like application ecosystem. The application ecosystem significantly influences operating system adoption. Software availability varies like dramatically between platform, often becomes the deciding factor for specific user cases. So the application installation and management, the tools of the system security, stability, and the overall user experience. So the development frameworks and API applications impact performance on the feature consistency across the operating system. So the backward compatibility approaches determine the longevity of the software investments and the traditions cost between operating system visions. So these are all for the enterprise integration. So we go with the next slide. Sorry, this is like next slide. This is enterprise integration. Enterprise integration capability often determine operating system selection in business environments. So directly service integration affects the development in organization environments or require centralized user and resource management. So the remote management capabilities determine the administration efficiency and total cost of ownership in a multi-system developments. So these are for the enterprise integration. We'll go with the market position and target users. So usually the market position reveals much about operating system design like priorities. So window domestic enterprise environment due to legacy application support and established IT management infrastructure. So Mac was targets creative performance and education section. So leveraging exclusive software and simplified management for these specific markets. So these are for market position and target users. So we'll go with the next slide. So this is like future development trajectories. So the future development trajectories indicate developing priorities in operating system design. So the good integration continues reshaping operating system with increased focus on synchronization service and distributed computing models. So the security hardwiring against the specified threats, device architecture changes, including enhanced memory protection and privilege isolation techniques. So the architecture influence of integration, enhanced user interface, and enable a protective system operating based on user patterns. So these are for the future developments, and we'll go with the next slide. So these are the conclusion and a final assessment. So the in conclusion, operating system selection should align with the specific user cases rather than like following in general market, traditional popularity. So the security models vary significantly in a multiplication implementation of the quality despite conceptual similarities and across the major operating system. So the performance optimization priorities reveal a fundamentals philosophical and a difference between an operating system and design approaches under their target audience, user interface of prediction condition between a touch-oriented mobile system and a traditional pointer. So based on desktop environments. So the integration capabilities with exciting infrastructure of the provide a few technical advantages and a practical development strengths. This is all for the conclusion. So these are for the reference links. So thank you for your attention and thank you so much.